Okay, let's go over to Advent of Code. We're going to look at day 2 today. And as an example, or as a refresher rather, yesterday I kicked off the series and we did some preliminary setup of how we think it's going to go, and I decided I'm going to use Vim just as a fun exercise. And also as a reminder, these code challenges, it's worth noting that we're not striving for any particular goal other than what's stated in the description here. So what I mean by that is that we are not necessarily going to be worried about performance or necessarily about long-term code design or trying to reach any sort of functional aspirations outside of our own curiosity. If there is a good suggestion on how we should do something, we can explore it. And ultimately, we'll just see where it takes us. And our goal is to solve the challenge and essentially no more than that. So I don't want to gold plate every single one of these. So with that out of the way, and feel free to stop me, ask questions, make suggestions, or whatever. Okay, so let's jump in. We will quickly go over to iTerm, and I have Advent of Code in here, and I'm using Vimmer, or Vimr, I'm not quite sure how to say it. This is essentially like MacVim, but for NeoVim, and it is written in Swift, uses RX Swift actually, and is my essentially NeoVim under the hood and uses my setup. So we have a day 1 example that we can run here. And I'm toying with this command, leader SB, to do a Swift build straight from Vim, and leader SR. And what I'm doing with this is what's changed from yesterday. Let me open up my Vim configuration real quick. So if we run a terminal command like bang ls, it opens up just the output of that command in this little discard area. This is not a Vim buffer, so there's nothing I can do about it. If I click or hit enter or anything, it just goes away. There's nowhere for me to copy the text from there. And so there were a couple of things I found. One of them is you can use the read command and then run ls, and notice that it put that straight in the buffer where my cursor was, which was pretty awesome. I had never seen that before. I think there's another way to do this where you can say read into a new buffer. I'm not quite sure what it was. Anyway, the problem there is you end up with these buffers that they want to be saved and stuff like that. So what I found online is this right here, and literally just copied and pasted and put it in here. The idea is instead of using bang to run shell commands, you can use this new command, capital S shell. And if I do shell ls, it runs the command and tells me how many lines there are. And when I hit enter, it opens that up in a scratch buffer that is not going to prompt me to save it. So this will show me the output. I can copy and paste or whatever, and then I can quit when I'm out of that. And so I have changed my my Swift run command to use this shell so it captures the output for us. So that's basically what I have in terms of the Vim setup. Let's go ahead and make a day 2 folder. And in there we'll make day2.swift. And inside of there we'll have enum day2, static func run. And then in main.swift, we're just going to run whichever example we want to. And so I'll just comment out the other ones. And then we will need day 2 input and test files. But for now, let's just read the challenge and see what we need to do. Okay, day 2, dive. Now you need to figure out how to pilot this thing. It seems like the submarine can take a series of commands like forward 1, down 2, or up 3. Forward X increases a horizontal position by X. Down X increases the depth by X units, and up decreases the depth by X units. Note that since you're on a submarine, down and up affect your depth, and they have the opposite result of what you might expect. The submarine seems to have already planned a course, your puzzle input. You should probably figure out where it's going. So this is our test input. Forward 5, down 5, forward 8. So it looks like we've got a direction and a number. And then we are supposed to, we start, our position and depth both start at 0. The steps above would modify them as follows. Yada, yada, yada. After following these instructions, you would have a horizontal position of 15 and a depth of 10. And you multiply these together to get 150. Okay. So let's go to, now in day1.swift, we just put all of our files right in here. We can continue to do that unless they get bigger, but ultimately everything's going to live within this day folder. So this will be a type, and if I need to namespace it, I can put it inside of the day 2 or whatever. I also don't know if any of these challenges are going to reference previous challenges, because I've never done Advent of Code before. Okay, so we want to call this maybe a position tracker. And the position tracker will have a position, a horizontal position, which will be an int, and a depth, which will be an int. And they both start at 0. So we can do this. And then we're going to have a series of, I don't know, movements. And I think the movement could be an enum where we have case forward, case up, and case down. And in each case, we have an associated value of an int by how much to move. The downside of putting associated values here is if I were to have this without the associated values, I could do this and get automatic parsing of these. So I could easily say, give me a movement from the string forward, and it would give it to me. But if we have associated values, we can no longer do that. So one option would be for us to have maybe a static func parse input, which will be a string, and this will give us an instance of self. And we have to consider, what do we do if we get garbage text? So maybe it returns nil, or maybe it throws an exception. I'll go with the nil for now. So we're expecting this to be forward followed by a number or whatever. So we can say input dot split with the separator of a single space, and that will give us our 2 parts. And we can say parts 0. Let's guard parts.count is equal to 2, otherwise return nil. For parts 0, we know that that's one of these things. So let's first grab the amount, which will be parts 1, and we will int convert that. And again, I'm going to use guard let, so if we can't convert it to an int, then it'll return nil. All right, so then we can switch on parts 0. And in the case of forward, we can return .forward amount. And we'll do the same thing for up and down. Now, one thing I just found out about yesterday, actually, is if you hit star, it searches for the word under the cursor. And that also puts it into a register. So now I can go down here and say %s. And if I do // it will replace the word in that register. So at this point now I can just start typing, which I think is pretty incredible. However, it doesn't help me. I don't know if there's a way for me to do it just on the one line, because obviously this is doing it globally. Because what I want to be able to do is say s / up, and I can do /g so it'll get more than one on a line. But I don't want it to do it on all of these. I would like it to just do it on the line I'm on. So I'm actually just going to do a quick search and say vim replace on line. Replacing a line with another one yanked before. No. Find and replace. So it's kind of like G is global, but I wonder if you can, let's see, what is confirm each substitution with a C flag. Okay, that's interesting. I could perhaps do that. Y to replace a match, or L to replace the match and quit. So that would be like, yes, do this one and continue, or last, replace it, and this is the last one. Case insensitivity, search range. When no range is specified, the substitute commands operates only in the current line. The range can be either one line or range between two lines. Huh. When no range is specified, the substitute command operates only in the current line. That's not what I'm seeing. Oh, but I did say %s, not just s. Let me try it like that. Let me do s / up. Ah, sweet. Okay, so % is the whole buffer. So here, if I want to search for forward, I'm going to hit asterisk, colon, s / down, /g. Sweet. And we will return nil if we can't parse anything else. Okay, so at this point, we've parsed a single line of movement. So at this point, we can say process movement. And that will do something. And in the end, we want to be able to grab our position and depth. And because I don't want these to be mutated outside of this, but I do want to be able to read them, I'm going to make these private set on both of them. So let's see. I'm trying to remember now how I did the... Nope, not like that. Oh well. Okay, so we'll need some input, which will be read file, and this will be day2.test. And then I want to get all the lines out of that. And we did this in day one, where we are parsing and we tried to get lines out of this. So I want to essentially grab these two and make those a utility function. So maybe I could say func dot, or maybe even extension string var lines gives me an array of string. And then I can just grab this and return it. So this will be split and then map trimming. And I think that this won't... Will this work? When you split a string, does it give you an array of strings or a substrings? Well, it is working and it's not giving me any errors, so... at this point, let's go back to day 2. And then I want to be able to say let input. So then movements is input.lines.map. And then we can say movement.parse. And because that can return nil, we want compact map, so we get only the movements that were valid. And now I want to say movements dot for each, and we need our tracker. And for each movement, I want to call tracker. I could do tracker.process, like that. And then we want to print depth is now tracker.depth, and position is now tracker.position. Okay, so if we were to build this, it works. And if we were to run it, obviously we're not processing the movement, but we do get the depth and the position. Okay, as we're processing these, it would be nice to be able to say, what I want to do is kind of replicate, well, I suppose I don't necessarily need to replicate their output. I could just say I'm processing a movement. Print processing movement, and I'll just output it like this. Okay, forward 5, down 5. Okay, looks good. And we can now switch on the movement. In the case of forward, we will increase our horizontal position by X. In the case of up, we will decrease our depth by X. And in the case of down, we will increase our depth by X. Let's see. Okay, so it's not mutable because this is a struct, and I'm not quite sure if I want to keep it as a struct or not. I don't think I necessarily want to. Basically, I would have to make this mutating, and if I do that, then I have to have this be var tracker, and you can't use partial application like this, so I would have to say for each tracker.process $0, and that works. Okay, depth is 10, position is 15, so our answer now is going to be print day to answer is tracker.depth times tracker.position. Okay, so we got our answer. Let's grab our new input for day 2.input. Get your puzzle input. Copy that, paste it. Okay. And now we can use day 2 input. Okay, and our depth is 1,000, position is there, and now I can copy this to the clipboard and paste it in here. Okay, that was pretty easy. Okay, continue to part 2. Any questions or comments or whatever before we dig into this? All right. So part 2. Based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is actually slightly more complicated. In addition to the horizontal position and depth, you'll also need to track a third value, aim, which also starts at 0. The commands also mean something differently entirely than what you first thought. Down increases your aim by X units. Up decreases your aim by X units. Forward does 2 things. It increases your horizontal position by X units. It increases your depth by your aim multiplied by X. Okay. Again, note that since you're on a submarine, down and up do the opposite of what you might expect. Down means aiming in the positive direction. Okay, that makes sense to me. Okay, so using our test input, we should be getting a depth of 60. We should get a 900 on our product. So let's go back over to here and we'll switch over to our test. Our position tracker needs to keep track of aim. And then when we go up, our aim is subtracted by X. When we go down, our aim is increased by X. And then here we have two commands. Position increases by X and depth increases by aim times X. Okay, let's run that and let's see the result. 900 looks good. So let's go up to the top and we will grab our input. It's the same input here. So we'll run, go down to the bottom, copy that, paste it. Okay, that's the right answer. Okay, that one was super easy. So I think we will move on to day 3.